Assalamu alaikum. My name is Atyam Khurshid, 19CE24 from Section D. My other group member names are Ehsan Ali Shah, Ali Hassan, Adil Shabir, and Muhammad Hamza. Uh, we have chosen the topic of SAP as a software, and in SAP we have to design the Warren Truss. For Warren Trust, we have a scenario that it has been designed for a truck having different loadings at different positions. As in the figure, you can see that the span length of the truss is 63 feet and it has a height of 13.64 feet. So, also, there are different loadings of truck with different wheels. For example, the back wheel has a load of 40,640 pounds, the middle has 40,640 pounds, and the front wheel has 10,160 pounds. The impact factor chosen for these loadings is 0.27. There are 7 possible different conditions for the truck on the variant truss to be placed on it to be moved from it. So for all these conditions we have to be considerate all these conditions for the designing of the variant truss. So this is a SAP interface. We have clicked on file, and from file we will draw a new model. So first thing we are here to consider is the unit system for the new model. As far as our concern, we have units of FPS units in our case, as you can see for these different types of loads of the truck and the other factors. So from here we will choose the loads of FPS. After choosing the units, we have different types of templates to be drawn on the software. In our case, we have 2D truss for our bridge. The 2D truss can be converted into the 3D. So we will choose 2D truss. Now we have to select different types of things in it, like the number of deviants in our bridge are. We can see that there are 1, 2, 3, and 4 deviants in our bridge. So we simply place a value of 4 in the number of deviants. Now we can see the height of our bridge. From this we can see that our bridge height is 13.64. So 13.64 value has been put in the height section. So other is the length of our bridge for one panel, that is 16.75. So here we will put 16.75 feet in the section and then press OK. You can see now the truss in the 2D plane as well as the 3D plane. So from here what we will do, that how we can convert this single side of the bridge into the double side of the bridge. We have different types of view options, as you can see, that is XZ view. So by clicking on any of the view, we can change the view. As you can see, the view has been changed on the right side of the window. Now, as far as our concern is for the truss system, we have to convert this 2D truss into a 3D bridge. So for that purpose, first of all we have to select all the members of the truss. For selecting all the members of the truss, we can click on each of the member or simply press Ctrl A to select all the members in a simple way. Now go to edit and press replicate option. From replicate we can make copies of this truss, but now we have to decide that in which axis we have to make the copy or copies of the truss. So we can see that there are 3 axes x, y, and z axis. So as far as our concern, we have to put the value of that our bridge is 26 feet wide. So the width has been given as 26 feet. So we will put 26 feet in the dy direction. So we don't need to give the units in the software because we have also given the units at the start of the software. So you can see that this truss has been replicated in the y direction. The other step for the truss designing is that we have to connect the upper chords and the lower chords. From the toolbar you can see that there is the option of draw frame or cable. By clicking on the draw frame or cable, we can have a cable element to connect the upper chords and the lower chords. We can connect these cable and the frame in the 3D view or either in the 2D view. That's up to us. So we have snap tools on. For this purpose we have click first point and then on second point right click, then we have chosen other 2 points for the chord to be drawn, and similarly in this way according to our figure we will design the chord. So it's mistakenly drawn, so for that purpose we can simply undo that option. So there's the undo option. We have undo the action and we have left click and then we have make the cable. So in the 3D view we have make the truss. So now we will convert this view in the 2D. So for this set 2D view, and from here we will put the value of z to be 0 in the xy plane, so that we will only able to see the xy plane. So this is the bottom portion of the both of the trusses. So we will again draw here the chords by left click, and then the other point we will join these points. So by right clicking we can escape this option. So in this way we have drawn the chords at the bottom of the direction of the truss. So we can see the 3D that we have joined our truss members. Here by default there are two supports assigned, that is hinge on the left side and the roller on the right side. So we don't need to assign the supports on the truss member. Now we have two things. Number one is defining the material, and number two is assigning the material. Before assigning any material to the truss, we have to define it. This is the define option on the toolbar, and this is the assign option on the toolbar. So first of all we will define our material. So by going into the define and the section properties, because we have a section for a truss to be drawn, so we will choose the frame section. Now from there we have to choose that which of the section we want to draw for the truss. So we will import the new property, and the section we have used is the I section for our truss. So we will click on the I section, as it is a steel section. This is the I section. So from here a new window is pop up, and from this we have to search our sections.pro. That are the different types of the sections in it. So this is saved by default, and now another window has been popped up which shows different types of the sections. For this we have to first define our material, and for the material the define material window has been pop up. We will click on add new material to add the material in it. So we have clicked on the add new material, and from there we will choose our standard, that is ASTM A36, and the grade we have to choose. The grade has been selected by default. So by pressing on OK we have assigned our material. So A36 has been assigned. Now the problem comes that which of the section we will choose. So in the problem statement it has been given to us that the area of the section is 20 inches square. So we will choose that section whose area is 20 inches square. So to understand this concept, that which section we have to choose, there are different types of websites and LRFT manuals. From there we can check the properties of our different sections. For this understanding I have gone into the website which shows different types of sections, either they are I, W, S, HP, or different types of sections. This website gives a vast majority of the sections, their areas and properties. So we will go into the wild flange steel sections. So from there by inspection we can see that W 10 into 68 has an area of 20 inches square. So that's a requirement, and other properties are also have been shown. But our requirement is that the area should be 20 inches square, because as per given in our statement problem, that the section we have choose has an area of 20 inches square. So by scrolling down, we have to now search the section of W10 into 68. So that's chosen. We will press OK. So the new window has been popped up, which shows different properties of the section, like its height, the flange width, etc. So these are the same that are given in the website. By pressing OK, we have now defined our section, that this section has to be chosen for our truss. Now we have to assign this property. For assigning, we will press Ctrl A. For simply selecting all of the members, click on assign, frame, and then frame sections. From this we will choose W1068. By pressing OK, we can see that W1068 has been assigned to all of the members, either they are upward, either they are downward. So for confirming that our sections have been assigned to the down chord members, we will cross check. So for cross checking, we will go to view and set the 2D view by doing XY plane and the Z value to be 0. We can see by pressing OK, we can see that the W1068 has been assigned. Now other step is to draw rectangular area. We will select first point, and then by dragging the mouse to the other corner, we have selected a rectangular area, and now on clicking on the select, we have selected that option. The other thing we have to do is to mesh it. So for meshing, go to edit and edit areas, dividing the areas to mesh that slab. So by doing so, we have to now choose the option that which type of meshing has been done. So for our case, we have to choose divide area based on the points on the area edges. So by clicking on this and checking the box below, we will divide our slab, the deck section of the truss. So now you can see that we have different types of sections of the meshing of the slab has been done. Let's go to the 3D view. We can see the areas meshed in the 3D view also. So now for recognition of these, we have to go into the set view properties options. Simply see their width or the extrusion. So by clicking on this, we have to select the fill objects and then press OK. So we can see that our area has been selected. We can see the area, the object has been filled. As the steel sections have been assigned their properties, now we have to define the material, that which type of material is for the concrete. For this we have to go into the section properties and then select the area section, and from this we will go into the new section and we will give it name like as concrete, because it has a property of the concrete. And as per given that we have to choose the strength of the concrete 4000, and what's the membrane thickness that we will choose is the 8 inches thickness of the membrane. So we will simply place the value of 8, and now as I have already mentioned that the units are already defined, so SAP takes the units very easily and conveniently. We will put 8 and inches, then press the enter. It would convert those units into the feet automatically. So by placing the value of 8 inches and pressing the enter value, so this is the value assigned. In the same way, we will provide the value of bending as 8 inches. Clicking on OK, the material has now been defined. Now we will assign the material that we have defined. For this, we have to click on the sign, and as this is our area section, click on the sections, and now the press on concrete, the selected deck would get the material of concrete. The other thing of concern is that we have to also define the property modifiers. So we have selected the deck. We will now assign the stiffness modifiers. So for that we will go into the sign area and the area stiffness model shell to release the moments. So here we will put the value of membrane F11 modifier to be 0 and similarly membrane F22 to be 0. By pressing OK, we have defined our stiffness modification factors. Now we have to assign the value of the live load. The live load is because of the movement of the vehicle on the bridge at the different movements at different positions. We have also introduced the impact factor for the design to be very good. This increases the chances of factor of safety as it has been designed for the more of the live load. So we can see that there are different loading conditions that are at the first the tire has been placed at the first joint, and in the second first tire and the second of the wheel has been placed, and in this way there are total 7 different conditions for which we have to design our truss. So or in first case there is the load of the front wheel on the hinge on the first joint. So we will select the first joint. The first joint has been two joints has been selected, and then assign joint loads. Click on the forces, and I have defined 7 cases as far as are concerned. So first we'll select our case 1. That is our cases. You can see dead and the self weight multiplier of the dead load as we know is 1, and we will apply the loads of the as we will apply the live loads on our model. So we will select the case 1, and as far as the loading is 10,168 because it is acting in the z axis because it is in the direction of gravity, not on the x and y axis. So it is in downward direction acting. So we have to take the sign of minus for this purpose. That's why this is the minus sign, is indicating that the load is acting downward. We have selected the joints, and this is the load value. We have selected the joints and then case 1 and then press OK, and now you can see that this load has been assigned to the first two joints, as if we consider the situation that it is the load of the first two vehicles on the joints plus the impact factor has been multiplied and then is added in it. So that's the first case, and in second case there is the 10,160 pounds applying on the second joint. So we will select these second joints first, go into the assign menu and select the joint loads. Now this we will select from here case 2, and the load that is acting is of the front wheels that acts on these joints. Now we'll select the backward joints and then assign the joint loads and then the forces. Now we will select here, case 2 has been already selected, and the value of the rear tires, that is 40,160 pounds, and then we will press OK. So this is the second condition of our truck. You can see that the front wheels and the third, and now this is the third condition where the 3 tires are acting. So the first we will select the third joints and assign this load. For that purpose we have to choose the value of the first wheels, that is minus 10,160, and in the same way we will select the 4 joints below it that has the same loadings of the rear tires. We will just assign the loads, the joint loads on these joints, and then we will select our case 3 has been selected and put the value of the lower tires and then press OK. In this way case 3 has been defined. Similarly we have to define our fourth case. So select these first two joints Then assign the load again in the similar way, forces, and then select our case 4 from this tab. As our case 4 has been selected, and we will put the load values of the first two tires, that is minus 10,160, and has been applied. Select the second and third joints and assign the loads of the second and third axle tires in the same way, nothing difference. So putting the value of the loads and then press OK. Now we want to check that our load cases have been defined accurately or not. For this we have to go to the display options and show the load assigns. Click on our case that which we want to see. Let's take a look on the case 1. So this is showing that in our case 1 the loading just acts on the first two of the joints, and also shows the values that 10,160, and by clicking on the arrow, this arrow, we can change our load case efficiently in no time. So we have clicked and we can see that there is a the load case 2. In the same way, we will move forward to see our other load cases. This is the load case number 3, that is on the upper tab you can also see, and then clicking again we can, in this way we can see that our load of what loads we have assigned, that is the load case number 4, and that is the load case number 5, the load case number 6, and the load case number 7. So this is the way we can see that our load that has been assigned is assigned accurately or not. After loads have been assigned, we have to run our model for analysis. We will click on the run analysis, and this is the window open. We have to select the dead load for the running pattern, and we will deselect the model because it is for the dynamic analysis. So we will click only on the dead and the other load cases for running. Click on run now, and it takes time for running. So it has run and it shows the reaction forces on the joints. The joint forces have been shown, and now I want to check some other information from the software. Let's click on the display option, and from this we can show the deformed shape of the bridge. So we will select or any of the load cases, say case 1, and then we can see that there is no deformation. That's because of on the first joints there is the reaction, that's why there is no load deformation. We will move forward, and now we can see that our bridge has been deformed, and the case 3 is deformation gets more and more. So it shows the analysis of our truss. So we will change our cases, case number 5, 6, the case number 7, and then the case number 1. Now we can also extract other information from the software. We will select the forces. What are the forces? So the forces acting on the frames or cables. So first of all we will select our required case, and then there are many options to get which type of force required, or if we are interested in finding our stress values, so we will choose. Then what is the component we have to choose? We have axial force, we have moment, we have shear, and we have torsion. So in our project we will choose the axial force, as we know that for truss members and the truss structures it is the only it has only the axial force. So we will select the axial force simply, because shear and other factors are not applicable in this. So the axial force has been selected. Now we have to see auto or the scale, and then the options of the that we have either fill diagram or show the values above. We have chosen the option of fill diagram. Press OK. We never see any axial force diagram because of the case 1. We will change the view to XC, because of the joint loads at point 1 we don't have the axial forces at it. We select the case another case, that is case 2. So we can see that there are different values of the axial forces in the different members. From here we have seen that there are two colors, red and the blue color. The red color simply shows the members that are in compression and the blue color shows that the members are in tension. So by moving the cursor we can read the value at any point, and the diagram also shows the intensity of the diagram shows that where the stresses are high, and the small rectangle shows that the stresses are low. So by moving the cursor we can read the value. We will move to our next case, third and fourth case. So fourth case is the case where maximum loading has been acting at the center of the bridge, that is approximately 75,000 by moving the cursor, and in the similar way it has been changing from member to member, changing case 5, case 6 and case number 7. No forces acting on the case number 7. Case 6 we can see the forces. Now we also get other information from the software. We will go into the display, show force and stresses. Now click on frame, cables and tendons, or we can also go into the this option from the toolbar. This also shows the same. Now we will select the show values. It will give the values of the axial force at different locations, because in the previous diagram we have just the colors, and by moving the cursor we can see, but in this diagram we can see the values of the stresses at different portions of the trusses. We can also choose the one last thing from the software, that is the steel design. The steel design would design the type of the steel. So by clicking it, we can see a color diagram. This color diagram simply shows red color and up to the blue color. The red color has a value of 1, while the blue color has a value of 0, which shows that the member at 1, that is red color, is overstressed, and the other members and the blue color is not overstressed, it is over designed, mean its cross section is higher, that's why it does not take much stresses. So from this color diagram we have to optimize our design, that whether we have to choose different types of sections for our truss case. But as per our problem, we have only chosen a single cross section of 20 inches square, that is W10 into 68, to just show the loads transferring criteria of the truss. So the goal of this diagram is just as simple as to choose the different cross sections based on different types of the stresses we get from this software. For example, we have in the blue color we have to reduce the cross section. By reducing the cross section we mean reducing the cost, but taking the factor of safety of the bridge into the account. So this is the design of structures in SAP that should be safe enough and economical and optimizable. That's all from my side. Allah Hafiz.